Hello, Johan. Thank you for the warm welcome and the nice tour at Melsen. Your facilities are indeed amazing and provide a very comprehensive view of what you're doing and bringing at the forefront the innovation character along the Sustainable Print Consortium. First of all, could you tell us something about yourself?
Thank you. Yes, I'm Johan Smed. I've been in the business for 41 years now. I started my education in 1983 and finished the education in 1986. Still though, there's a lot to learn in the business, a lot to learn about screen print, so I think it's a lifelong learning process. So I don't think I have finished my education yet.
Can you tell us something about screen printing?
Screen printing actually is one of the oldest printing techniques in the world. It was invented, some say in China, some say in Japan, several hundred years ago. It started out as human hair, as a mesh, and then later on it became silk woven as a mesh. So it was put on a wooden frame, therefore we know it as silk screen printing. Nowadays it's more like a polyester mesh on a metal frame. Therefore, we can use it as an industrial standard today. The frames, as I said, was polyester mesh mostly. They can always be other things like nylon or metallic mesh also, but mostly polyester. And the aluminium frames are used because they are stable. And on the mesh, we put an emulsion to make the screen that we need to print. The emulsion is then made with a CTS. It's a computer to screen. It's a laser that makes the motif that we need to print, or with films and a metallic halide lamp. We need good frames, we need stable frames, and we need a good mesh with a stable mesh tension to make it more accurate in the print shop. Printing machines, there are several types of printing machines. There's half automatic printing machines where you put in your sheet and the machine prints the motif, and then you take out the sheet and put it through the dryer. There's also machines where you put in the sheet and the print machine does a print run and then take out the sheet and put it through the dryer. There's a cylinder machine that takes the sheet, print it, put it through the dryer and stack it in the end of the machine. And there's also roll-to-roll machine that print from one roll, dry it and put it on the same way the roll in the end of the machine. The ink that we use today, they are mainly three types, and we use them because we need to be conductive. So we have to put them through the screen, and the pigment size decides which screens we're using. They're going to be very stable, so we want them to evaporate in the same amount during the whole printing process. We don't want the first print to be different from the last print. So that's the main thing we can say about that.
Thank you. When having a look at printed electronics in general, how do you believe will the market evolve in the future?
I'm pretty sure that the market will grow rapidly in the future because printed electronics is used in so many ways today. It's going to be used in the health industry, in the transportation, for RFID antennas, sensors, and everything. So the market will grow very rapidly.
Before you mentioned about the inks something, I wanted to ask what kind of inks do you use for the screen printing?
We use mainly three types of inks now. The silver, because it's the most conductive ink we have, and then we print on top of that, we print carbon to prevent it from migrate, and then we got dielectric to prevent when we make crossovers, so we are able to cross two lines, and also because we want to protect it from moist.
Do these inks demand a special treatment or storage?
The dielectric is UV cured, so we need to store it in black containers to prevent it from be damaged from the light sources that we got around us. And the silver must be stored cool, but the drying process is a bit hard because it needs a high temperature to dry. So we want to go lower on the temperature, but at the moment it's not possible.
Which are the most important sustainability issues of printed electronics?
I think the hardest part of sustainability is to find materials that can be separated and reused, because it's very hard to take the things apart now as it is now and then use them again. So either we've got to find something that is not harmful in the nature, or something that can be taken apart and reused. That's the main issue.
What would you say is the lifetime of printed electronic components?
It's very different, because when we got several different types of printed electronics, and you could see it in the health industry, you could see it in diapers. You could use a diaper for some hours in the health industry, maybe for a day or two. And then we got our membrane switches that can last for 10, 15, 20 years. So it depends on the application, but from hours to many years.
Which are the most important parameters during the printing process?
The most important thing is to get a proper drying of the silver and the conductive inks and the dielectric, so it's stable. And we got to have the same amount of material put through the mesh, so we got the same layer of ink on every print that we do, because then we got the same conductivity from start of the print run to the end of the print run. That's the main focus that we have to do. And then we have to align every print on top of each other so it can be used in the process that's going to finish the product.
Last but not least, I would like to ask you if you have any suggestions to develop us in the future.
The most important thing that they got to think in the production lines. So we can do at least 800 prints per hour, and not just one or three to test if it's okay. We really got to think as a production and in industrial production, and then maybe go a bit lower in drying temperature, and we need to have inks that can stick very hard to the substrate that we print on, so it won't delaminate when used in many years. For instance, for membrane switches. That's the main thing. And no water-based materials, because printed electronics don't like water. They will not work with that. That's the main thing, I think.
Thank you very much for your time.
You're welcome. This is a circuit made for a membrane switch. First, we print the copper or silver ink, as you can see here. On top of that, we print our carbon ink to protect the silver or copper ink. Here, the green part is a dielectric, so we can print a crossover here to make contact from here to here. And on top of the whole thing, we print a dielectric to prevent the whole circuit. Here we can mount LEDs, and here is the bottom layer of our buttons. Now we're starting our printing process. She puts in the sheet in the machine. And here we go. Now the squeegee takes the ink through the mesh, and the flutter comes back and fill the mesh again. The angle of the squeegee must be approximately 75 degrees. Otherwise, the ink will be pressed through the mesh. We don't want that. We want the mesh that the flutter fills in the mesh to be the one that comes on the print, not anymore. If you lower the squeegee angle, you'll press the ink through and you won't get an even print. So 75 degrees is the most accurate. Here again, first the squeegee, and then the flutter comes to fill the ink in the screen. And the principle of all machines are the same, but they're just different types of machines that they're printed on. These machines are the slowest types of machines because you gotta put the sheet in by hand, take it out by hand, but the automatic machines will do the job for you, so you will only need to watch the quality of the prints and adjust the machine. To get a good alignment of every print on top of each other, we have markers on the print table where the sheets are put into, 2 in the bottom and 1 in the side. Here you can see how the sheet are put into the front and the side layer. The table has a built-in vacuum mechanism, so it's held tightly. And when you print the sheets, you can ensure by using the front and the side layers that every print is aligned on top of each other. Here you can see the front from the side, the print stroke. First the squeegee, and then the flutter fills the mesh when it goes backwards.